In today's video, we're going to take a look at a new family of functions for us, and those are the exponential functions. And first off, we're going to start off by defining an exponential function, and then we'll dive into some graphing and some equations involving exponential functions. But first, we have a definition here. An exponential function is a function of the form f of x equals a to the x power. And you may have to pause the video here to get some of the rules down and make sure you're okay. But some of the key things to look at here is the form of the function, f of x equals a to the x power. We call this a base a function. So notice that the variable here is the exponent here is the variable, and just a couple of restrictions here. A has to be greater than 0. A can't equal 1 for some obvious reasons. If a equals 0, then we have 0 being raised to powers, and that's no fun. And a can't equal 1 because that's no fun either. And also x is going to be any real number we like. So some restrictions, but most of them should make sense if we go through the problems. So we're going to graph 3 of them. You have some graph paper in front of you. I'm just going to have some coordinate axes here and make some cruddy looking graphs out of it. Hopefully you do a better job with it. So our first one is 2 to the x power. Like any function we want to study, we want to make an xy table here. So we have x and f of x. And we always want to plug some values in that make sense, like 0, 1, 2. And we're also going to look at some negative values as well and try to make some sense out of what's going on here. So when x equals 0, we have 2 to the 0 power. We know that that equals 1. When x equals 1, that's 2 to the first power. That equals 2. And then 2 squared is 4. And you start to get an idea of what's happening here is that these outputs are going to keep getting bigger and bigger. So let's go ahead and plot those. 0, 1 right around here. 1, 2 right around here. 2, 4 up even higher right around here. And you can see that this thing is just going to keep going up and up and up in this direction. But as we use negatives, the negative first power, remember what a negative first power does. That is the reciprocal function. Whoops, not a negative here. That is the 1/2. So f of x equals the 1/2. And then the negative 2 would be to 1/4. Okay? And that means that when we have negative x values in this direction, the outputs keep getting smaller and smaller. Right? So it'll look like this, and it will hug this. It does have an asymptote here at 0, so it stays above the x-axis. It's just these outputs, like if we put a negative 3 in, we get 1/8. They'll just keep getting smaller and smaller. Okay? Closer to 0. All right, next up, how about f of x equals 1/2 to the x power? Same procedure. We're going to just take a look at the behavior by plugging in some representative x's. Let's use the same set we did before. Let's use negative 2, negative 1, 0, 1, 2. And if we need any more points, we'll do that. It's easy to start in the middle here. F of 0 we can see will be 1. F of 1 we can see will be 1/2. F of 2 is 1/4. So let's go ahead and plot those. 0, 1. 1, 1/2. 2, 1/4. It'd be 3, 1/8 as well. So this thing is just going to keep getting smaller and smaller. But look what happens when we plug in some negative x's. 1/2 to the negative first power. So 1/2 to the negative first power just means the reciprocal. That becomes 2. So negative 1 gives us 2. And negative 2, by the same process, will give us 4. And you start to see what this one does. It does kind of the opposite of what the last one did. It's actually symmetric about the y-axis as the problem we just had, as opposed to this problem. You can kind of see the symmetries going on here between the last one and this one. Okay, one last one to look at, one last graph to look at anyway. F of x equals 3 to the, we got a nasty looking exponent there, to 2x minus 4. So again, we're going to plug in some values here, some x, and get some f of x's. Let's be a little bit more strategic about this one. This one will still have the same basic shape. You'll notice that most exponentials kind of have this zooming off into infinity kind of shape. Just got to figure out which one it's going to be here and how it's going to work out. And I'm feasting my eyes here on this exponent. For example, if I plug a 2 in for x, well, I know that 2 times 2 is 4 minus 4 is 0. That'll give me 0 my exponent. That will give me 1 as an answer here. What if I plug in something like, well, let's plug in 0. What happens if I plug in 0? If I plug a 0 in, I get 2 times 0 is 0. I get 3 to the negative 4th. Oh, that is not nice at all. But we know that's 1/81st. That doesn't look good at all. That's not promising. What if I plug a 1 in? If I plug a 1 in, I get 2 times 1 is 2. I get 3 to the negative 2nd. That's 1/9. So maybe I'm starting to make some heads or tails here. 2 gives me 1, so right around here. 0 gives me 1/81st. That's not fun at all. 0 gives me 1/81st, it'll be right there. 1 gives me 1/9, and maybe I'm starting to see the behavior here as to what's going on here. What if I plug in something like 3? 2 times 3 is 6, minus 4, I get 3 squared now. That's 9. Now I'm starting to get an idea of it here. It seems like it zooms up like this. And the general idea is it's going to go like this. Okay? We're not going to deal with too many that look nasty like this, but you get the idea that these guys can move around a little bit. Okay. Next problem. Now we have some equations here. The second half of this unit will be on exponential equations. You may have encountered these before. The idea here is right now I can't solve it because I have two separate bases. I have 4 and I have 16. But if I think about what I'm allowed to do in algebra, which is I can replace equals with equals, this all works out very well. I'm going to leave the left-hand side alone at 4 to the 3x minus 1. Keep in mind that 16 is the same as 4 squared. So I'm just replacing 16 with 4 squared. That then gets raised to the x plus 2 power. So keep in mind the step here. I replaced an equal with an equal. That's just substitution. Left-hand side stays the same. Right-hand side, by the laws of exponents, becomes 4 to the 2x plus 2. And look what I can do here. Since my bases are the same, that means I can equate the exponents. So 3x plus 1 equals 2x plus 2. Do a little bit of a razzle-dazzle here. We can see that x has to equal 1. And we're all set to go. And you can check and verify that that's true. Okay. Here's our next problem. And before our next problem, it's time to reveal the Jolly Rancher word of the day. The Jolly Rancher word of the day is photosynthesis. Photosynthesis. First 5 people tomorrow. Photosynthesis. Okay. Here's our next problem. 2/3 to the x power equals 9/4. This one looks nasty, but you need to think a little bit. I need to rewrite this so both bases are the same. So you need to think to yourself, what are both sides of the equation powers of? And take a minute and think about that. Well, actually, if you think deeply about it, they're both really powers of 2/3. This is 2/3 the x power. I'll leave that be. 9/4 is a power of 2/3. You have to do two things. You need to take its reciprocal, and you need to square it. So 9/4 is the same as 2/3 to the negative second power. You see how that would work? Because I would take the 2/3 and flip it, and I'd also square it. And now I'm all set to go. Now I have the same base. That means that x equals -2. So these ones get a little trickier, but you have to ask yourself, how are you going to get them to have the same base? All right, last problem for today, and this is kind of the challenge one. Oh, I thought I had a problem written here. I guess I don't. The last problem in your sheet, which I do not have handy. Okay, through some pause magic here on Doceri, I was able to pause the video and find the problem that you guys have, which is 2 to the x minus 1 equals 7. What I want to challenge you guys with is, how do you think we're going to approach this one? Is there any way to get these two to have the same base? I have a 2 and I have 7 here. I have two mutually prime numbers. They don't share any factors, so it doesn't look real promising. So I want you to think about what techniques could we use to solve a problem like this. And this is going to really become the focus of a lot of what we do in this chapter. So exponential functions, we're going to have some fun with them because the word problems do get kind of nice in this chapter. And make sure you come in and see me tomorrow with the secret word.